Everything around us is always in motion. I mean, from a simple walk down the street to a planet hurtling through space. But if you really want to understand how things move, you need more than just speed. And in this explainer, we're going to unlock the fundamental concept of velocity.
Okay, so check this out. If I told you a car was moving at 60 kilometers per hour, do you really have the whole story? I mean, you know how fast it's going, for sure. But is it heading into town? Is it going north? South? This one simple question gets right to the heart of what we're talking about today.
Yeah, to really get a grip on the world in motion, we need a little more detail than just the number on a speedometer.
And this, right here, is the absolute heart of it. See, velocity isn't just how fast. It's a total package deal. You get the speed of an object plus the direction it's going. You've got to have both.
So let's dig into those hidden details that make velocity so much more powerful than just a single number from a radar gun.
In the science world, velocity is called a vector quantity. Now, don't let that fancy term throw you off. It just means it's a measurement that needs two parts to be complete: a magnitude, which is just the number, like 60 kilometers per hour, and a direction, like east. That's it.
So we can actually break this vector thing down even more. First, you've got the speed, which is the easy part, how fast. Then you have the path it's on, which you could call its direction, like, say, an east-west highway. But is the car going towards the east or towards the west? That specific orientation, that's called the sense. Now, for our purposes, we can pretty much just bundle direction and sense together and just call the whole thing direction.
Okay, and this leads us right into the single biggest mix-up. I mean, people use these words, speed and velocity, interchangeably all the time. But in physics, they are totally different. So let's clear this up once and for all.
All right, let's paint a picture. We've got two people and they're both out for a run. We clock them and they are both moving at a steady 10 kilometers per hour. So far, so good. Their speeds are exactly the same.
But here's the twist. Here's the key piece of info. One of them is running straight north. The other one is running in the exact opposite direction, to the south. And this changes everything.
And boom! This is what perfectly shows the difference. If you only ask about their speed, the answer is they're the same. But if you ask about their velocity, the answer is they are completely different. And why? Because their directions are opposite. That's the power of velocity. It gives you the full, complete story.
Now let's take that idea just one step further, because this is a really cool example. Think about a cyclist on a circular track, right? And they're holding a perfect, steady speed, say 20 kilometers per hour. Their speed isn't changing, but because they're on a circle, they are constantly turning. Their direction is changing every single second, and if the direction is changing, then their velocity is changing too.
So we get what it is, but how do we actually measure it? Well, there are two main ways to look at velocity. You can look at the big picture of a whole journey, or you can zoom in on a single snapshot in time.
First up, we have average velocity. Think of this as the big picture view. It honestly doesn't care if you sped up, slowed down, or stopped for coffee. All it cares about is your displacement, and that's just the straight line distance and direction from where you started to where you finished, and you divide that by the total time it took.
Let's make this super practical. So, you leave your house, you walk to a park that's exactly 500 meters to the east. It takes you 100 seconds to get there. To find your average velocity, you just take the 500 meters and divide by 100 seconds. What do you get? Your average velocity was 5 meters per second to the east. Simple as that.
But what about your velocity right now, at this very instant? Well, that's called instantaneous velocity. And honestly, the best way to think about it is the speedometer in your car. When you glance down at it, it's not telling you the average for your whole trip, right? No, it's telling you your speed at that exact moment. And the direction you're pointing, well, that's the other half of your velocity.
All right, so let's pull this out of the world of thought experiments and see how we actually see and use these concepts every single day.
One of the best ways to actually see velocity is on a simple graph. If you plot an object's position over a certain amount of time, a nice straight sloped line means its velocity isn't changing. If that line starts to curve, its velocity is changing. And here's the really cool part. The steepness of that line, what mathematicians call the slope, that tells you the velocity. A steeper line means a higher velocity.
And of course, we need units to talk about this stuff. In physics class, the official unit is meters per second, or ms.
But out in the real world, for our cars and travel, we all use kilometers per hour, or km per hour. Oh, and here's a handy little conversion for you. 1 meter per second equals 3.6 kilometers per hour. So if you're jogging at, say, 3 meters per second, you're actually cruising at over 10 kilometers per hour.
And this table, wow, this really puts the whole concept into perspective. Just look at the incredible range we're talking about. A person walking is moving at about 1.5 meters per second. A car in the city is about 10 times faster. But then, just look at the speed of sound, and then the speed of light in a vacuum. It's just a mind-blowing scale, and this one idea, velocity, is how we describe it all.
All right, we've covered a fair bit of ground, so let's boil it all down to the absolute essentials you need to remember about motion.
So what do you absolutely have to take away from this? Number 1, velocity is always speed plus direction. That means it's a vector quantity. Remember the 2 main types we talked about? Average for the whole trip and instantaneous for right now. And maybe the most important thing, speed and velocity are not the same thing.
And that's really what's so incredible about this whole idea. This one concept, velocity, is the language we use to describe everything, from a tiny atom buzzing around to an entire galaxy spinning through space. So the final question I have for you is this. Now that you know, what movement in your own world seems the most incredible to you?